Investigation of flexural properties of solid wood materials reinforced with various VRP. Wood is a building and engineering material with a wide range of uses with its many positive properties. Biological structure, physical and mechanical properties, and chemical composition allow wood to be used in many different products. The fact that wood is a good insulation material and its resistance values compared to its density are among the reasons for preference. Wood material can be destroyed over time due to different environmental factors, for example, insects, fungus, rainwater. When the studies on the behavior of beams against the bending test are examined, it is known that fracture occurs on the bottom surface of the material. Fiber-reinforced polymers are a scientific fact that reveals that fiber-reinforced polymers should be preferred in the solution of the problem, as they can be applied without damaging the wood appearance, as well as their properties such as lightness, corrosion, and flexibility. In this study, it was aimed to investigate the effect of reinforcement with carbon, glass, and basalt-based polymer fabric on the bending properties of ash beams. Carbon, glass, and basalt fabric technical properties. After the priming process, the wrapping process is carried out with the adhesive. Fiber polymers fabrics are placed on the surface by stretching in the direction of the fibers by applying a layer of adhesive and in order to absorb the adhesive into the fabric. Air gaps are removed by pressing in the direction of the fibers with a ruler. Then, the second layer of adhesive is applied to the fibrous polymers fabric surface with a ruler, and the fiber polymers is laminated between two layers of adhesive. The image of the VRP polymer and reinforced beam uses in this study is given in figure. The wrapped beams were kept for 1 week before being subject to the bending test. In the bending test, the loading speed was set at 6 mm/minute constant speed and the experiments were carried out. The span of the support points was taken at 300 millimeter in the experiment. The 3-point bending test experimental setup image is given in figure. Load displacement graphs and flexural strength modulus of elasticity in the study are given in figure. It was determined that the load-bearing capacity of the beams reinforced with carbon, basalt, and glass-based VRP polymers increased by 57%, 36%, and 4.6% respectively compared to reference sample. It was determined that the displacement amount of the reinforced beam increased by 40%, 3.4%, and 1% respectively in carbon, basalt, and glass-based fabric compared to the reference beams. Flexural strength values of the beams reinforced with carbon, basalt, and glass-based polymer fabrics increased by 24%, 18%, and 8% respectively compared to the reference beams. The modulus of elasticity values increased by 23%, 18%, and 5% respectively. Thank you for your attention.